Hi, today I will be talking about confounding, its definition, and some of the remedies to combat confounding. Let's take a look. So let's start with the definition. Let's say we want to explore the causal hypothesis of does a certain exposure cause an outcome. So now what is confounding? Generally, it is something that causes confusion when investigating a scientific hypothesis. It is unclear whether the exposure is causing the outcome, something else, which is the confounder, is causing the outcome, or you're seeing a mixture of something. More formally, it is a third or a different variable than the exposure and the outcome, which must be causally associated with the outcome, it must be causally associated with the exposure, and it cannot be an intermediate effect, meaning the exposure cannot cause the confounder, in this case variable 2. It is also worth noting that there can be other pathways that can be confounding pathways, and there can be more confounders. Such diagrams are called DAGs, which is directed acyclic graphs. I also want to add this notion of confounding by indication or contraindication. Sometimes people will use these fancy terms, but it is nothing more than confounding by the medical condition. Now, how does a medical condition behave as a confounder? Well, that condition can be related to the outcome, it can cause the outcome, and it can also be related to the exposure in the sense that that exposure might be indicated for the condition or might be contraindicated for the condition. And that is confounding by indication or contraindication. Now let's jump into some simple intuitive examples, not only to learn about confounding but also to see the remedies for confounding. Let's say we want to investigate the causal hypothesis, does consuming bananas cause lung cancer? At first it may seem very weird and absurd, but let's persevere through this example. To investigate this hypothesis, I recruit a group of people who are complete banana consumers or banana eaters. I recruit a second group who are non-banana eaters or non-banana consumers. I will compare the rate of lung cancer between the eaters and the non-eaters. Fine and dandy. But it gets more complicated when I dive into the particular characteristic of all these individuals. What do I observe? I observe that all the people in my banana eating group are actually smokers. And all the people in my non-banana eating group are non-smokers. Now that's a problem that we have. In this case, we can say that it's confounded by smoking status. What is really happening? So in the banana eaters, there are more smokers, or all of them are smokers, and it should not come as a surprise that smoking causes lung cancer. So in the banana eaters, the rate of lung cancer will be higher, which is denoted by the upward red arrow. And the opposite situation occurs in the non-eaters, which is, since they are non-smokers, the rate of lung cancer will be lower, thus widening the gap or the chasm, and leading us to believe that banana is causally associated with lung cancer, but that's actually false. That's just an association, that's not a causation. But we saw this because of confounding. So this is the problem, that smoking is causally associated with lung cancer, it is associated with banana eating, and it is not an intermediate effect. So how do we solve this problem? Let's get into the remedies. So the first remedy is restriction. What I'm doing here is restricting everybody in the banana eating and the non-banana eating group to being a non-smoker. Nobody should be a smoker. So essentially what I'm doing is everybody in my comparison, I'm restricting to one of the level of the confounder. So the smoking confounder can have many levels as non-smokers, mild smokers, heavy smokers. I'm restricting them to just one level of the confounder, thus breaking the relationship between smoking and bananas. And now if we compare with the previous slide, the banana eaters and the non-banana eaters, the two groups are essentially the same, making the comparison a fair one. The second type of remedy is matching. This can also be viewed as restricting to smokers, just like the previous slide. But since I wanted to introduce this notion of matching being a remedy for confounding, I'm introducing it in that spirit. But of course, I would also mention that matching is much more complicated. But just for illustration purpose and the completeness of this video, I'm introducing matching as one of the remedies for confounding. And thus we can see, just like the previous slide, if we restrict everybody or if we match everybody on the same level of the confounder, the problem goes away and it becomes a fair comparison. The second remedy is regression. Now, from the group level, I am diving down to an individual level. So we are comparing these two individuals and they have similar smoking habits. So these are just two people from my data set. One of them is a banana eater in the yellow and the other guy is a non-banana eater. And both of them are smokers. And then we see who has lung cancer and who does not have lung cancer. And since the outcome is binary, we will do a logistic regression model and get the odds ratio with these calculations. Thus, that odds ratio will be the association between banana consumption and lung cancer. But it will be a fair one because now, even at the individual level, these two people are comparable. That's a fair comparison. So the third remedy is stratification. We are interested in the causal association between bananas and lung cancer, and we want to get rid of confounding by smoking. So the overall table that we had between lung cancer and banana eating can now be stratified on the levels of that confounder, just as I introduced this notion previously. So the first confounding level or first confounding stratum is all smokers, and the second confounding level or second stratum is all non-smokers. And what we can do is we can get the effect estimate or the odds ratio for the smokers denoted by phi s and phi ns for non-smokers, and then we can re-weight it back for our entire population using the Mantel-Hansel technique. That's what is represented by the phi mh. So stratification and Mantel-Hansel technique is also one of the remedy for confounding. Yet another technique to control for confounding is randomization. So I have a mixed bag of people. I randomly assign a few to eat bananas and I randomly assign a few not to eat bananas. Now because of the randomization, what we see is there is a fair balance of the characteristics in the banana eating group and in the non-banana eating group. Meaning the problem that we had initially, that the banana eaters were exclusively smokers and the non-banana eaters were exclusively non-smokers, now vanishes, thus controlling for confounding. Although I will mention that this randomization of exposure needs a human ethical consideration, and thus we should be very aware of whether or not the exposure can be assigned or not. There are two more techniques to control for confounding, namely standardization and inverse probability weighting, but I have reserved those for a future video. Thank you.